So here I have the second part, just looking at just a couple more of these exponent laws from the same section of the textbook. And so for this example right here, I have 2 times 3 all to the power of 5. And again, the key to this is the purpose is not to try to evaluate these. The purpose of this is to try to find other ways of writing it, realizing these properties of when we're dealing with powers and exponents. So if I have 2 times 3 and it's all being raised to the power of 5, what does that mean? Well, this means 2 times 3 times itself 5 times. OK, so how can I write this in a different way, though? What's this property I'm trying to get us to look at? Well, in the end, 2 times 3 to the power of 5, same as 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. Well, I have a whole bunch of multiplication going on right here. And the order we multiply never matters. So if I want, I can change the order of this around. And notice in the end, I have a whole bunch of 2's. I have 2 times itself 5 times. And I have 3 times itself 5 times. And this here kind of illustrates this exponent law we want to see, which is anytime you have a few different factors, 2 times 3 are both factors, all being multiplied to the same power, if you want, you can write it as each of those factors individually being raised to that power. So 2 times 3 all to the power of 5 is the same as 2 to the power of 5 times 3 to the power of 5. And so in general, if I have 2 different factors, a and b, all being raised to the same power, if I want, I can write it as just a to the power of x times b to the power of x. And vice versa. Anytime I have 2 different factors but being raised to the same, or 2 different bases but being raised to the same exponent, if I want, I can write it as a single exponent with both those bases being multiplied together, as you see here. And we never want to forget that you can look at any of these either way. Right? Most often we look at it this way, but you can also look at it this way. And the only other exponent law I want to look at is the same idea, but with dividing these numbers instead of multiplying together inside the power. So I have 2 divided by 3 to the power of 4. And so, how can I rewrite this? Well, let's first think what this means. This is the same as 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. 2/3 times itself 4 times. Well, I'm multiplying a fraction repeatedly. How do we multiply with fractions? It's really quite pleasant. Just multiply the numerators together and multiply the denominators together. So in the numerator, I have 2 times 2 times 2 times 2, or 2 to the power of 4. In the denominator, I have 3 times 3 times 3 times 3, or 3 to the power of 4. And this here gives me a sense about this property I'm trying to exemplify here. Because notice, if you have a fraction, or really a division statement being raised to a power, if you want, you can write it as just the numerator and the denominator separately being raised to that power. And vice versa. You can go this way, you can go this way. Or in general, if I have a over b, all being raised to the power of x, if I want, I can think of it as a to the power of x divided by b to the power of x. And again, if this is correct, this must be correct. All right, and that completes these, or completes the introduction of these exponent laws that we're looking at in this course.